My name is Mr. Cosmas Rotich from Emining Technical Training Institute. Emining Technical Training Institute is found in Baringo County. We are here to participate on a robotic contest, and the theme of this year, we are trying to mimic the voting pattern, the election, how we are going to vote in the next general election. So we are here with our robot. And what it does is that it picks it goes start from the starting point, goes to pick the ballot paper. That is after passing through the verification desk. Once it picks the ballot papers, then it goes through the boot, the boot, and then it drops the ballot paper and at the ballot box. We have got 3 ballot papers. That is green, the blue, yellow, and the red. So you have to pick all of them, and then make sure that you've dropped them at the ballot box. So the speed at which you are going to use for your robot might determine if you're going to win or not, and also if you achieve to pick all your targets, that is all the 3 ballot papers. This robot, how we've come with it is that we have got the mechanical part of it, we have the electrical part of it, and we have got the ICT part of it. That is the fabrication, and then the connection, and then now the programming part of it. So in our programming, we are using the Arduino board, and the motors, that is the DC motors to drive the wheels. We have got the servo motors which controls the arm. In our case, this acts as an arm, as the human arm. So it is being controlled by the servo motors, to allow that movement. So these servo motors are being are programmed. They are programmable. That is, we connect them to the Arduino, and then you program them. Also, we have got the sensors. We have got the sensors. We have got the line tracking sensors. You can see this is our line tracking sensor. That is so as to track the path, so that the robot does not miss a path. So we have got the line tracking sensors. So we have got the left, the center, and the right. So our purpose is to make sure that the right sees the white part, so that it keeps moving. So that is the purpose of this line tracking, is to help us in achieving the movement. Also, we have got it is being powered by the battery. This is the LiPo battery. We have got the 2 of them. One is powering the motors, and then the other one is powering the arm. This one acts as our carrier, where we are going to place our ballot papers before we take them. Our intention was to pick all of them. That is, pick one, drop here, pick another one, drop here, and then move with another one. The reason why we decided that is to achieve the speed, because our competition, we are supposed to clear in 3 minutes. So instead of we saw that instead of picking one, dropping, and then coming, we may not be able to achieve that target. So we decided we design a carrier so that we pick one, we place here, we pick another one, we place here, and then the last ballot, we are going to go with it up to the boot. So basically, that is our design, and we hope to achieve our target at the end of the competition. Thank you very much.
Oh, I'm Edwin Migai from Masai Technical Training Institute, taking a diploma in mechanical engineering. This is our robot. Its name is Masai Tech Robot. This is not our first robot. This is our 6th or 7th time to build a robot. And this robot, its constituents is, first it is automated. After you switch it on, it should do everything it's programmed to do. So this robot, these are the wheels of the robot, which makes it to travel across that grid there, that game field, and with the help of other components here underneath, there are sensors, color tracking sensors.
15 minutes from now.
And here in front we have obstacle sensors. I don't know whether you can see them. They are here. Now this is used to determine whether there is an object in front of the robot. This robot tracks a line, which means on that grid there it follows a straight line. If you want to steer the robot, you just steer either to make a 90 degrees turn or 100 degrees 180 degrees turn, and then you will turn the way, you will steer the robot the way you want. We follow rules. Under these competitions, there are rules that you are given. There are the limitations under the rules, which tells you which robot you are supposed to make. By that I mean that you should not exceed some limits, and there are some rules. For example, if you look at that grid, it is divided into small boxes. So the robot there is supposed to track those lines. So you should not make a robot which is so big. There is the limitations. For example, there is it is supposed to be less than 60 centimeters wide. No, the robot, it should not exceed 60 centimeters by wide and length. So you have to make a simple component that can pick those boxes there. Those boxes might be cylindrical, might be cuboid, might be cubes, according to the rules that you are given. And then you have to make a robot which can do that automatically without any operator interfering with the robot as it is working. So some of the challenges that we face during making these robots is that, one thing, this robot should work as a human. That's one thing. And making a robot to think or do or act like a human is hard. So programming is one of the challenges, which means you have to program it perfectly to do according to the rules. And you are not given, you are just provided with some funds to buy some materials, and then you can make your robot the way you want. You can design the way you want. And that's another challenge of designing the robot, because you can design a very big robot, but you don't need a very big robot. You just want a very small robot according to the rules. So that's another challenge. So there's challenge of like wiring. You see these robots uses a lot of wires. That electrical part, it's also so delicate. So which means you have to be so keen when you're doing the wiring. The robots we are supposed to make, you should not import or bring some new components to them. Everything you must make. Despite like some things, like it uses some sensors which we can't make here in Kenya, so we have to buy those. But some components like grippers, those other wheels, you're supposed to come up with those ideas to how to make them, and then the design itself of the robot. You should not import anything. That's according to the rules. It should be homemade, locally made. This idea is to develop robotics in Kenya, in which we use our resources, the available resources that we have in Kenya, to build robots here, which means everything you see here is around us. It's not something that is so compact that you have to import from Japan. No, it's just around us. But by that knowledge of combining those things and compiling them, you come up with a robot. So these robots like here, this is like a chrome. This thing here. In fact, to make this, we just have less or like 10 months to come with a design to make a new robot and bring it up here to competitions. In fact, this is not the first competition, so you have to make it earlier. Like you have less than 5 months to make a robot in order to get to the regionals, to get the nationals, and then here in a coast. So this means that you have to be very quick, and that's another challenge because you have no time and you have to make a very good thing, a very good component. Like here this is a demonstration of a voting exercise. These robots are like voters, so they have to pick these boxes and put them to their respective in process of dropping them. So they are just like voters, considering that we are going to a voting. We are just going to vote in maybe next month or what. You see, so 3. Yeah, so it's just like we are just like mobilizing people. So it's used to mobilize. Like now we are mobilizing people on voting, so that we don't have some people who are not voting. If a robot itself can vote, why not a person? So that's the theme of this year's program of robotics.
My name is Elijah Kembenya from kicc University, Department of Aquatic and Visual Sciences. So what we are doing here is that we want to conserve a fish called Bell victorianus, locally known as Ningu, that is endemic to Lake Victoria, and it is endangered because it appears in the IUCN red list of endangered species, and the populations in Lake Victoria are going down, and that's why we want to conserve the species. The populations have gone down because of predation by Nile perch, which was introduced to the lake, overfishing, climate change, and among other factors. So what we are doing currently is that we capture the fish from the wild, manipulate their reproduction by inducing the females with a hormone. The hormone is a commercial name is Overprim, but it is like any other reproductive hormone in animals that quickens the process of reproduction. So when we inject the female, we fasten the process of ovulation, doing that within a very short time, at the mean of 11 hours, you will find that the female will lay eggs. So we pair them. After injecting the female, we pair it with a male, so that in a tank, of course, with water, and then we leave them to coat and lay eggs. So after spawning, we separate the eggs from the fish, and then we set the right temperature and the right dissolved oxygen concentration, and then until the eggs hatch. After hatching, we still raise the fish under the same conditions, same temperature, about 28 degrees Celsius, of which we feed the larvae with zooplankton, which is a live feed, for 1 week or so, and then we wean the fish to very finely ground freshwater shrimps, and from the stage of when they attain fingering stage, we feed them on a feed with a higher protein level, about 40%, which is of course formulated at our laboratories. And then so what we want to do is that we do a mass production of these fish. We get enough fingerings so that we can restock to the lake to increase the numbers of the population of this species. Although that one has not been achieved yet, we have not restocked, but the first phase of the project is that we have been able to produce fingerlings, and therefore the next step is to do mass production of the same and restock the lake. Another objective that we have in this project is that we want to test the aquaculture potential for these fish, whether it can be cultured by farmers alongside other 2 fish species which are grown in Kenya, that is the tilapia and the catfish. So this one, if it proves to be a good aquaculture species, it will form the third species to be cultured by farmers. But that one, we are not there yet, because we want to grow it for the next 1 year, or we want to see again how long does it take to attain table size, and what kind of aquaculture system does it prefer, which feed, crude protein level feed, that gives us the best results. So we are testing the fish on different diets of fish with different crude proteins, using local available material, food ingredients, and also different aquaculture systems, that is tanks, in concrete ponds, in liner ponds, to see which the one that gives us optimum production. Yeah, so at the end of the project, we'll be able to conclude and give our recommendations whether this fish is
I'm Kimutai Caleb, a student of Meru National Polytechnic, studying automotive engineering, module 3.
Hello everyone. I'm Kipkoech Collins, student from the Meru National Polytechnic, taking automotive module 3.
Okay, I'm Kelvin Mogambi. I'm a student at Meru National Polytechnic. I study diploma in electrical and electronic engineering.
Okay, morning everybody. I'm Alex Kirima in Meru National Polytechnic, taking a diploma in electrical and electronic engineering, module 3.
My name is Kefa Mwiti. I'm taking diploma in ICT. I'm in module 2.
Joyce Mokami is my name, pursuing ICT, module 1.
We are glad to share with you the idea we have with our robot. And first of all, our robot starts with 3 departments. We have mechanical, electrical, and ICT. And today we are going to tell you and teach you some lessons, few lessons maybe. But first, let me give my friend, my colleague, to start with the electrical part.
As you have heard, is that in our robot we have 3 components. We have the mechanical bit, electrical bit, and ICT and programming. So for me, I'll start with the electrical part. Starting with the electrical part, we start with the powering of our robot. We are using 2 repo battery. The first repo battery has a capacity of 14.8 volts, 5.5 amperes, and the second one, it has a capacity of 7.4 volts and 2.4 amperes. From the powering, we go back to the H-bridge. The H-bridge is the one which coordinates the powering of the robot. Then from the H-bridge, we go back to our motors. Motors still will be powered through the H-bridge. Then from motors, we have 2 parts of motors. We have the DC motors, which are using our wheels, and we have the servo motors for our gripper. We have 3 servo motors. This is the first servo motor of gripping. We have another servo motor here and another servo motor at the base here. So we have 3 servo motors. The others are 2 DC motors. And in tracking, we normally use our robot. We use tracking. We have our sensors. We have 4 sensors. 4 sensors which we normally use for tracking. Those are the eyes of the robots. Then from the sensing, we have now the Arduino board, which is normally used to coordinate. It is the brain of the robot. That is the last part, the brain of the robot. Now, from there, I'll give my colleague to explain the mechanical bit.
Welcome again, ladies and gentlemen. Having gotten the idea of electrical part inside the robot and the Arduino part, that is the ICT programming system, coming to robot building or body of the robot is not much something difficult for somebody. First of all, you have to take care of the electrical components, make sure that they are fixed inside to avoid movement, to avoid shock circuiting, and to make your robot, in any case that any problem may develop, you can easily access, you can easily note where the problem is. But first, the edge bridge, we must mount the edge bridge. In our idea that we mounted the edge bridge to reduce on space and at the same time fix the battery in a locked position to avoid moving. And over here, we fixed the Arduino board for the display. We got our display here. So display, we managed to come up with correct measurements to avoid elongation or shortening of the display at the back, that is. And basically, if you can see the shape of the robot, is that as an automotive engineer, we decided with my colleague, let's come up with a streamlined body. Let's come up with a body just like a vehicle. As you can see, we choose to take this as a operation of a bonnet, because if it was a windscreen, if the robot was required to have a windscreen, then this could be a simplest way to fix a windscreen. So we didn't choose to open our robot from the back or from the front, but we choose the roof part to enable us access inside much quicker and easily. And when you come to the front, we designed to have a streamlined body. As everybody knows, that streamlined body move faster in motion and resistance reduces in resistances. So we wanted to reduce on force resistances so as to enable our robot to move at higher speed. That is, and coming to the arm, making arm was something not very difficult, although it requires a lot of technical capacity, a lot of measurements, but we managed in our workshop. Since we got machines, we have been told how to operate the machines. So out of the machines, we managed to come up with the arm. But basically, we have some photos showing up the process of the robot manufacturing and to the spring. But since we got less time and we are much curious to go to the field, then let me just say that I am grateful for letting you know that the Meru National Polytechnic Institute, not more than what everybody can judge from outside. And I welcome you all to the Institute, where you can find your true dreams and make your life better. Thank you.
So finally, after we have designed the body and then we have been able to decide the electrical part, now what we are remaining with is the movement of the robot. So from there, that's now where we require the IT professionals or the IT people. So I and my colleague, we decided to program it with our board. That is an Arduino board. So we have an Arduino language that is called Arduino C that we use to program. And basically what we do in the programming is that we code the sensing of the robot, that is the movement, through the use of the sensors that they have been fixed by the electrical people. And then from there, we are able to also control the movement of the body or the wheels through also the program, so that if it encounters a white junction, it is able to count. Like it's able to count 1, 2, 3. From there, turn right. We give that instruction through programming of the Arduino C. And we also have another programming bit. That is the programming of the display. It's an RGB display, so we programmed this. So it's also able to display the names. It's able to display the names of us, just as you can see. Yeah, name of the school, name of the team Raya, which we are presenting today. That all this work is all about programming work. From there, what we can just say that this one is a wonderful project, just as we have been able to work with our colleagues. And we feel encouraged that when we see this thing winning and winning all the time. So let me say thank you so much. It's good to have Elimu, and we are happy for everything. Thank you so much.
MKU doing engineering. We have a device here to present. The device is alcohol ignition interlock. Normally used to disconnect the engine in case of problem of if you are drunk. This one normally avoid drunk driving. Therefore, it has sections. It has the camera in this case for capturing the one that is being tested. Then it has the control device. It is this one, the control device, and of course it has the sampler, a small device for testing the whatever that you are being tested in. Then we have the control circuit. This control circuit is one that is used to disconnect the engine, the vehicle. Then for testing, you have to swipe the device on this, and then in this case, you apply your whatever that's before the it is getting ready right now. It's ready. Then after some time, you are time out. Just again. To make sure that when you are applying it's consistent. So this camera is for the one that is being captured. To capture the one who is being tested. Then let me just swipe this. Swipe this. Like get ready. It's telling you to get ready. And after sometimes you provide the sample again. Yeah, pass. You can see you're okay. You're okay now. The person who has been tested seems that he has not taken any means, for instance, if it is drunk, then to disconnect, to give the message there saying that you cannot drive. It cannot allow you to drive. So that's all about the device. The main advantage of this is that you not get the contact with them. It's all about that. So does it use power? Yeah, it normally uses power. You can use AC power from the mains. That's AC power. The mains. It's locally designed. It's not a complicated system. It's local. It's now being developed so that now can put in the market.
Kevin Wage, Stephen Kenyatta University. Basically, my background is electrical engineer from Wikipedia Chandaria. So I have a product, a medical device. It's just like an ultrasound, handheld, and it will come with a software, a mobile application. So basically what it does is like detect anomalies in pregnancy, and once someone like using it when it's scanned, I incorporated machine learning so that at least the scan itself, it will be smart. You scan it, can automatically tell you the detection or the diagnosis of the image itself. So that's basically how it works. I have a simulation here. How it works. This is the transducer. Yeah, we used a curve so that we can have an outline of the shape of the object. So another one for machine learning, we use TensorFlow so that at least we train this machine fast. We feed a lot of images so that at least when we do a scan, it's automatically like fetch from the store images related to one you are describing. So this is how it works. So we use TensorFlow here. We have images here, name, products. It can give you probabilities. And it's early pregnancy, its score is 29%. Pregnancy. That is another one. So the score for that one is 0.7%. There it is. So about these 10 subphones, it will be on a mobile application. It won't be on a hardware, it will be on mobile application. You scan it. The device, every about our strategy, business model, and our partnership. At least when we get there, we will be stable. And this device will be cheaper than the current one. It will be available to those people in slums or marginalized areas. And it gets the reduction for mortality rate will be reduced from the research, which says it's 56%, will be reduced, let's say, to 35%. That's what we are targeting as our thing, Ultraman is.